All right, day 20, Sohcahtoa. You may have heard of this before. You may have done this before. Not quite sure, but I want to go back over it and make sure that that you know how to do this because we're going to really begin getting into our trig units now. And this is the first unit of trigonometry, and basically we'll be doing trig for most of the rest of the semester. Sohcahtoa is something that you can use with right triangles only. Only works for right triangles. And basically what we're going to do is I'm going to show you how to find the ratios associated with the right triangle using sine, cosine, and tangent. All right, so let's just say we have a right triangle here. I know it's a right triangle because there's the 90-degree angle. And let's say that we have an angle theta down here in this bottom corner. Okay, now based on where that angle is, we have three sides to this triangle. We have a side that is opposite of the angle. So we call that the opposite side. We have a side that is next to the angle right here. In other words, one of the angles that forms, or one of the sides that forms the angle. We call that the adjacent side. And then you have the side that's opposite the right angle, which is always called the hypotenuse. And so whenever you have a right triangle, you have three sides. The hypotenuse is always opposite of the right angle, and that's the longest side always. And then you have an opposite and an adjacent side, which are basically the legs of the triangle. Now, since it is a right triangle, the Pythagorean theorem still holds true, which, if you'll remember, is a squared plus b squared equals c squared, and we just used that when we were doing hyperbolas in our last unit. But this is where Sohcahtoa comes in. The S stands for sine, and then the O and the H is telling me the ratio for the sine of theta. So if I'm looking at the sine of theta, the O stands for opposite and the H stands for hypotenuse. So the sine of theta, which the sine of this angle, is equivalent to taking the opposite side and dividing it by the hypotenuse. Again, SOH, that's where that comes from. And then cosine, if you look at cosine here with Sohcahtoa, again, we have the A and the H. That would be the adjacent side over the hypotenuse. And then tangent, the TOA, is opposite over the adjacent. So if you're looking at our Sohcahtoa, there's your SOH, CAH, TOA. Okay? Now let me show you how you're going to use this with writing the trig ratios and then solving some problems with it. So this example I'm going to give you is actually going to be number 1 on the worksheet you're going to do in class. You're going to do a worksheet like this in class. I'm actually doing these first 3 problems right here. So when we look at this, it says write the trig ratios for sine, cosine, and tangent, and then we're given this right triangle. And in order to write the trig ratio, though, we have to know all 3 sides. So the first thing we have to do here is we have to figure out what this side is here. Okay, so the way we're going to do that is we're going to set up the Pythagorean theorem. So I'm just going to do a squared plus b squared equals c squared. I know that c is 13 because that's the hypotenuse. It's opposite the right angle. The 5 can be a or b. It doesn't really matter. I'm just going to put the 5 as my b, and then I'm just going to solve this out. So a squared plus 25 equals 169. Subtract 25. So a squared equals 144. And then we square root, and we get a equals 12. So this side is 12. So I now have all of my sides. So since I have all the sides, I can do my ratios. Okay, and here's how the ratios work. Notice it says the sine, cosine, and tangent of A. We're all using A. So here's the angle that I'm looking at, is angle A. So it's like my theta is down here in this corner. So if we're looking at our triangle, 5 is the opposite side, 12 is the adjacent side, and 13 is my hypotenuse. So now I'm just going to do exactly what the ratios say up here. The sine of A, it's opposite over hypotenuse. So it's going to be 5 over 13. Done. Okay? Cosine of A, adjacent over hypotenuse. So the adjacent side is 12, hypotenuse is 13. And then tangent is the opposite side over the adjacent side. And that's doing your trig ratios right there. Very basic. And that's what you're going to do on the front side of the worksheet that I give you in class tomorrow. Okay. Now, you can also use the trig ratios to solve triangles, solve for the sides of a triangle or solve for the angles of a triangle. I'm going to show you how to solve for the sides of a triangle, and I'm going to do these two examples here, and then you're going to have some problems on the back of the worksheet tomorrow to work in class. But these are special right triangles here, but we can still use Sohcahtoa to solve these. Zoom in a little bit here. Okay, so we're looking at this first one here. We want to solve this for x. Okay, well, if we're looking at this problem, x is my hypotenuse. Okay, now I can use either angle that I want to use here. I can use this angle down at the bottom or this angle at the top. I'm just going to use this angle down here at the bottom. So we're going to use this angle down here, and that's going to be like my theta. Okay, so when I look at this, I'm given this side right here, which is the adjacent side. So what I need to do now is I need to decide, okay, I have the adjacent, I want to know the hypotenuse, so which formula or which trig ratio should I use? So I need to find the one that deals with adjacent and hypotenuse, and that is the cosine. Now, instead of putting theta in here, I'm actually going to put in the angle measure that they give me, which is 45 degrees. So when I set this up, I'm going to say, okay, cosine of 45 degrees equals the adjacent over the hypotenuse. And now I'm going to solve this for x. And the way we do that, I'm going to multiply both sides by x. So I have x cosine 45 degrees equals 5, because the x's cancel there. And then I'll just divide both sides by the cosine of 45, which you can do in your calculator. You do need to make sure that your calculator is in degree mode. So right next to the second button here, if you'll press the mode button, you'll notice you've got all these different modes in here. You want to go down to the third one and make sure that it is in degree mode, because we are doing things in degrees. So I'm going to quit out of that, and now I'm just going to go 5 divided by the cosine of 45, and I get 7.07 or 7.1. I'm just going to round it off. So x is 7.1, and that's my answer there. Okay? All right, let's do another one here. Let's do example 2. Okay, so here again, 30, 60, 90 triangle now, which is a special right triangle. We're going to use Sohcahtoa. X again is my hypotenuse here, because it's across from the right angle. Now this time I'm going to use the 30-degree angle here. That's going to be like my theta, which means the 8 is the opposite side. So again, if I'm looking at my trig functions, I want to use the one that deals with opposite and hypotenuse, which that's going to be the sine. So I'm going to set this up as the sine. Now my angle is 30 degrees, because that's the angle I'm using here, equals 8, which is the opposite, over x, which is the hypotenuse. Now we solve this the same exact way. Multiply both sides by x. So we end up with x sine of 30 equals 8, because the x's cancel there. And then we take our calculator, and we're already on degree mode. So all we have to do now is divide both sides by the sine of 30. So we just take 30 there. 8 divided by the sine. Put parentheses there just to make sure. And we get 16. So x equals 16. That one came out nice and even, which was nice. And that's solving using Sohcahtoa. So you have some problems like that tomorrow as well. You'll have a worksheet in class tomorrow to complete, and you'll turn that in, and then I will see you guys on Monday.